Hello again and welcome to the wonderful world of physics. So what we're going to be doing today is velocity and also distance time graphs. So we'll start off with velocity. And the big question is velocity. What is it? So velocity is how far you travel in a given time. So, things involved with velocity are going to be distance, or displacement, distance, and time, because it says how far, which is distance, time. Now, some of the common units that people are going to be used to, if you've ever driven a car or anything like that, is kilometres per hour. And you'll notice this here, kilometres, this is a distance. This is a time. So this is the amount of distance you go in a given time. So basically we can turn this into equations, because the whole point of physics is to turn stuff into equations. So velocity is equal to d per means divided by time. So distance, because we're using SI units, that's going to be measured in metres. Time is going to be measured in seconds. And this is velocity. Okay, one really important thing here. This is the average velocity. What that means, and this is really important, is there is no acceleration. We'll define acceleration later, but it's really important. There is no acceleration. This is an object travelling at the same speed all the way across that distance. And that makes a big difference. If we're going to take into account acceleration, we've got a whole series of equations that will do that, but that's not today. That's a later day. So let's try an example. So Usain Bolt is having a bad day, runs 100 metres in 10 seconds. What is his average velocity? Because there is no acceleration involved, we can just use the equation we were doing before. Velocity equals distance over time. So, remember we've got a whole series of steps. Draw a picture, running time, d equals 100 metres. T equals, so we write down what we know, d equals 100 metres, t equals 10 seconds, v is going to equal distance, 100 metres, divided by at the time, 10 seconds, and 10, so 100 divided by 10, and the unit is going to be metres divided by seconds. So 10 metres per second. Okay, so let's try another one. A bus travels 3 kilometres in 5 minutes. 10 minutes, let's make it 10 minutes. Must be one of those slow intercity buses, inside city buses, intra-city. What is velocity? It's the average velocity. So, in this case we're going to take the bus. So, again, step one, draw a picture. Now you know why I'm a physicist and not an artist. Write down what we know. D equals 3 kilometres. T equals 10 minutes. Okay, an important thing here, if in doubt, always go back to the base units. So always go back to meters and kilograms and seconds and Kelvin. So always go, so let's convert this into base units. So D is equal to 3,000 meters. T is going to be 10 minutes times 60 seconds per minute equals 600 seconds. So let's try this. So V is equal to D over T, because that's the formula, which is equal to, distance is 3,000 meters, time is 600 seconds, equals 5 meters per second. Okay, let's just do one last one. But remember, no acceleration, we can use this one. Let's just try one last example. Let's go for a bus again. Bus travels at 36 kilometers per hour, or 20 minutes. Yeah, 20 minutes. How far does it go? How far did it travel in that time? Because we know the average velocity, 36 kilometers per hour, in that time we can give it a crack. So first step, draw a picture. Step one, always draw a picture. V equals 36 kph. Okay, so and we know the time. So, step one, draw a picture. Step two, write down what you know. Step three, choose an equation. V is equal to D over T. Step four is rearrange that equation. So let's rearrange that. I want to find out D. So what I'm going to do, multiply both sides by T. Cancel, so D is equal to VT. If you're not familiar with rearranging, then look at the videos I've posted earlier on rearranging. They're lesson 0, how to rearrange equations. So, what we're probably going to have to do is convert these numbers into base numbers. So, 3,600, so let's try that again, 36 kph times, there's 1,000 meters per kilometre, and divide that by 3,600 seconds per hour, because remember it's kilometres per hour, so each hour has got 60 minutes, each minute has 60 seconds, so 60 times 60 equals 600. So basically we're dividing that, that's going to equal 10 metres per second. You should probably guess that's not coincidental. Yeah, that's good. Okay, what we know, so we have time, so that's equal to 10 metres per second. Time is equal to 20 minutes. So again, we go 20 minutes times 60 seconds per minute equals 1,200 seconds. So now that we've got these in the base units, we've got them in seconds, and we've got them in meters per second, we can go and work it out. So the velocity is 10 meters per second times, remember when we just run two numbers next to each other, that means times. Times 1,200 seconds equals 12,000 meters. Does that seem reasonable? Yes. That's one thing you do when you're doing engineering and physics and stuff. Whenever you come up with an answer, you've got to ask, does that seem reasonable? So does it seem reasonable that this bus has travelled 12 kilometres in 20 minutes or a third of an hour? That's a third of that. So yeah, it does seem reasonable. Okay, so that's basic velocity. This is for when there is no acceleration. I cannot stress that enough. No acceleration. When we go to acceleration, we'll do some extra stuff on that. Okay, so next clip, distance time graphs, and how to get velocity.